Okay, morning. This is Physics 1, Chapter 3, and we'll be talking about potential and kinetic energy. We're going to talk about what is energy. We'll redefine some terms that we talked about earlier. Define potential energy and see what that is. And we'll talk about units, measurement of length, weight, volume, and how we do that in science. And we'll talk about the conversion of energy from potential to kinetic energy. And we'll define kinetic energy and give you some examples and see what influences it. And we'll talk about kinetic energy in work, because that's how work gets done, is using kinetic energy. Now, definition reminder: energy is the ability to do work. The gentleman shoveling snow is using energy because he is doing work. Work is the result of a force moving an object a certain distance. So what he's doing is scraping up the snow in his shovel, and he's moving it someplace else. So he is doing work, and if you know the weight of the snow and how far he moves it, you can actually calculate how much work he's doing. I know personally it's a lot of work because we have to shovel a lot of snow in the wintertime. Now let's talk about units. Units are what we use to measure things. When you talk about running a race, you might talk about the 100-yard dash, or running a marathon, which is 26 point something miles. When you cook, you might use a half cup of something. When you step on the scale to see how much you weigh, you weigh that in pounds, at least in this country. These are all units of measurement that we use to see how big, how heavy, how much something is. Now, two systems in the world. Most of the folks in the world use the metric system. Countries in red use the British system. Mainly the United States, the lower 48, you can see Alaska up there, and the Hawaiian Islands out in the mid-Pacific Ocean. Interestingly enough, the British do not use the British system anymore. One little country in Africa and a country in Asia use the British system. Everyone else uses what's called the metric system. Different kinds of units. The metric system has one set of units, and they're in multiples of 10. The British system, on the other hand, is a little more arbitrary and has a variety of units that don't make that much sense. For example, the yard was established first by an English king who said the yard is the distance from my nose to the tip of my finger when I stretch my arm out. Well, that's really helpful. Now, if you get another king, you get a different system, a different measurement for the yard. So we needed something a little more systematic. Now, scientists around the world, in the United States and elsewhere, use the metric system because that's a common system that people are used to, and it's easier to work with. So if we're measuring volume, we measure it in milliliters and liters. We can weigh things in grams, kilograms. Another way to refer to this is the international system of units, or the Système International, as the French put it. So the scientists will use the metric system. Different units of measurement can be converted. We can convert inches to centimeters from the British to the metric system by multiplying by a certain number. And so we have conversions for the different values so that we can tell one from the other. Food labels. We notice that food labels in the United States actually are using the metric system. The amount of fat and cholesterol and sodium, etc., in this food are all in grams, which is a part of the metric system. And if you go to the store to get soda pop, you can get a large bottle that is a 2-liter bottle. It's a little over 2 quarts, but it's about 2 liters. It's 2 liters, and it's called a 2-liter bottle of soda pop. It's not a 2-quart bottle. Okay, potential energy. Potential energy is that energy that has potential to do work. It hasn't done it yet, but it's ready to go. You've got potential energy when you're laying in bed ready to get up. You haven't gotten up yet, but you have the potential to get up. And if you don't, you probably get in trouble with your folks. The book on the table has potential or stored energy. It's there, it's ready to go, it has not yet been released. If you push the book off the table, the stored energy is released, it's converted to kinetic energy, it's moving, and the book can land on a peanut and do work, like breaking the shell of the peanut. So that energy has to be released. As long as it's on the table, it's not released, and it's just waiting to be used. Other examples of potential energy: a battery is stored electrical energy. The chemical processes are in the battery, ready to go, but the energy is not released. The electrons cannot flow until there is a circuit for them to flow through. So it's just sitting there waiting for something to happen. Food is stored biochemical energy. The tacos and the refried beans and the yellow rice, sounds good, doesn't it, are stored biochemical energy. You eat the food and the body stores this energy until you need it. And then when you have to run a race or clean up your room or whatever, you have biochemical energy that allows you to move your muscles, move your body, and convert that potential energy into actual kinetic energy. Potential energy, as I said, is useful only when it's changed into another form of energy. It's sitting there ready to go, but it's not doing anything. Potential energy of a battery is useful only when it turns on a light in a flashlight, starts a car, or makes something else happen. I have a battery in my car, and it's sitting there. It's in the garage, and it's not going anywhere. And that's potential energy. But when I put the key in the ignition and turn it on and start the engine, then it is doing something. It is making something happen. It has to be converted to kinetic energy. Kinetic energy is that energy associated with things that are moving. Kinetic means moving or motion. So you have to make something move in order to do actual work. The amount of energy is conserved. The amount of potential energy equals the amount of kinetic energy. It's just in a different form. But we don't create new energy, we don't destroy energy, we just change it from one form to another. The amount of kinetic energy available depends on the mass and the speed of the thing doing the work. More mass equals more kinetic energy. The heavier something is, if it's moving, it has more kinetic energy. And if it's moving faster, it has more kinetic energy than something's moved slower. For example, if we take a pellet rifle and shoot at a building, not much is going to happen. We may chip a little bit out of the side of the building, but not really anything's going to happen. The pellet is a very light piece of item, so it has very low mass, so it won't have that much kinetic energy. On the other hand, if we swing a ball, a heavy metal ball, at a building, you can see we can do a lot of damage to the building because there is more mass in the ball. More speed equals more kinetic energy. These two cars are about the same, so they have about the same mass. If you have a collision at a low speed, you might get a dent in the car, you might bend the fender a little bit, but you're not moving very fast, so you don't have as much kinetic energy. On the other hand, if you have a collision at high speed, well, you got a real mess there. High speed, more kinetic energy, you do more work, so you rearrange more parts of the car in the process. Now, you can put the two together, and if we have a running water out of a faucet, we have a small mass, not a lot of water coming out, and we have a low speed. So we're not going to get a whole lot of work done out of that. On the other hand, if we have a large mass, a lot of water flowing on a river, for example, and a high speed, we can do a lot of work. This is a water is generating electricity, this photograph of a hydroelectric plant. So a lot of water flows through, and it flows through fairly fast, so we can make the turbines turn and create electricity from the flowing water. Now, what we've talked about, we've defined potential energy, has the potential for doing work, but is not actually doing work, but it's ready to go. We talked about the units of measurement, and we're going to be seeing this over and over again, the metric system and the British or the English system. We discussed energy is converted in order to do work. It's converted from potential energy to kinetic energy. Kinetic energy is the energy of motion. Things have to move in order for work to be done. And there we go. Thank you very much. I enjoyed spending time with you, and we'll see you later.